The main topic that we're going to cover now is learning and thinking and talking all about quadratic equations. So we're going to sort of define what they are. We're going to solve quadratic equations, and then talk about graphing quadratic equations. So a lot of stuff about quadratic equations. And then after that, if I can spell, we're going to go and look at solving quadratic inequalities where we have a greater than and less than. So a lot of stuff to do. So what I thought I would do, let's just, in terms of defining quadratic equations, the first kind of equations that we work with or that we're taught in algebra is a linear equation. Linear equation, I'll say with one variable. And the key is, when you look at a linear equation with one variable, there's no exponent on the variable. 2x plus 1 equals 4x minus 6. It's an equation, well, one variable, but you notice there's no exponent. And we know how to solve this. The way we solve a linear equation like this is we get all the terms with the variable on one side, we get all the terms without a variable on the other side, and we go from there. So we first add, subtract, move things from side to side. So for instance, subtract 2x from both sides. And then add 6 to both sides. And then divide by 2. And this should be the solution to the equation. In other words, this is the value of x that if I plug in to the original equation works, makes this equation true. All right, you guys know how to do that pretty much. That's a linear equation. What's interesting is when we graph this linear equation is always a straight line. So whenever we graph a linear equation, it's always a straight line. And if you recall the pretty famous slope-intercept equation, you notice here's the variable x with no exponent on it. That's because that's a straight line. All right, but now we're going to look at quadratic equations. And the thing that makes an equation a quadratic equation, once again we'll say with one variable, is that the variable is squared. In other words, has an exponent on the variable of 2. So, just some random examples of quadratic equations. It's a quadratic because the variable is squared here. Here's another quadratic equation, the variable squared. You may have something like this. Because you have parentheses, however, if you multiplied out the parentheses, you would end up with an x squared term and an x term and a number. So in a sense, although it doesn't appear obvious at first, this is also a quadratic equation. So a linear equation, no exponents on the variable. Quadratic equation has an exponent of 2. Now what's interesting is, if we talk about solving quadratic equations, there are actually, when I talk about this, in my mind, there are 4 different ways that people will go about solving a quadratic equation. Now what's interesting is the method we use to solve a linear equation does not work with a quadratic equation. In other words, if I get all the x's on one side and the number on the other, I'm sort of stuck. My ultimate goal is to get x equals something, and I can't do that really with these terms. So the old way doesn't work, so we have to come up with new ways, and there are actually 4 methods. And here's the interesting thing, of these 4 methods, 2 of the methods will work for every single quadratic equation. They always work. And then 2 of the methods, which are actually oftentimes a lot easier to use, only work sometimes. So a lot of times when you're asked to solve a quadratic equation, you may want to first investigate the easier methods. If they happen to work, then you can save some time. But then sometimes, if they don't work, you have to use the other methods. And then some people don't want to even take the time to check out the easy methods. They'll just do it the long way. And to some extent, it's totally up to you. If you're given a problem in the homework or on the test, and it says solve a quadratic, it's really up to you. They may say in the homework, do it a certain way, but to be honest, I don't think the computer knows how you solved it. They're just going to check to see if you got the correct answer. So let's talk about the 4 ways to solve it. The first one, I think you've probably learned before, and this is one of the reasons that you're taught to factor. Oftentimes, we can factor. This is a trinomial. As it turns out, it does factor. Right, factoring a trinomial is where you trying to look for 2 numbers multiplied together that equal 5, and then when you add the same 2 numbers together, it equals 6. So factoring means you take the 3 terms that have been added together and you convert them into 2 terms that are multiplied, and these are called factors. When you multiply things, they're called factors. And furthermore, it's very important when you solve a quadratic, one side has to be 0. And since it's 0, the way we can solve this is a solution, it was in either one of these parentheses equals 0. So if we look at the first parenthesis and we say what value of x would cause the first parenthesis to equal 0, obviously if x is minus 5, the whole parenthesis equals 0. 0 times anything is going to be 0, so therefore negative 5 is the solution. The second solution, if we look at the second parenthesis, would be negative 1. So then those are your 2 solutions. And of course, when you're always solving equations like this, especially on a test, when you're done, you should check your solutions. You plug minus 5 in for x, make sure it works. Then you go plug minus 1 in for x. Now what's interesting is something to note, and we've talked about this before with looking at solutions of polynomials. You notice the degree, the largest exponent is 2. That almost always means there's going to be 2 equations. For a linear equation, the little example problem I did, the degree of the equation was 1, which means there's going to be 1 solution. So normally when we solve a quadratic, there are 2 solutions. Sometimes they're repeated, So it looks like one solution, but there are always going to be two solutions. Let me do another quick factoring problem. You may have something like this. I'll teach you another way in a minute that's also very easy to solve this, but for now let's just factor. This is a difference of squares, so I'm going to factor it. And then I get a solution of -3 and 3. Factoring doesn't always work. You may get a trinomial, a quadratic equation, where it doesn't factor. Okay, so obviously you can't use factoring. You have to use one of the other methods. But if it does factor, and if the factoring is easy, then that's a pretty quick way to usually solve an equation. The second method, which works sometimes, and if it does work, it actually is pretty simple, is what I call the square root method. And that's where, this is a case, here's an example, the problem I just did. There will be occasionally quadratic equations where if you get the squared variable, you can get the squared variable by itself on one side, or a squared parenthesis, and I'll do an example in a minute of that, and then you can easily solve it. In other words, normally when you solve a quadratic equation, you have one side equal to 0. But when you use the square root method, what I'm going to do is I'm going to move the number to the other side. And now over here, all I have is x squared. My ultimate goal is to somehow convert x squared to x. How do you take something squared and turn to x? Take the square root. Of course, I have to take square root of both sides of the equation. Square root of x squared is x. Square root of 9. A lot of students will put 3. That's not correct. Have to put plus or minus 3. From now on, anytime you take the square root of a number, you always have to have the plus or minus. So you notice, here's my solution. Same thing as when I factored. So sometimes you have this, which makes it very easy to solve. Here's another example. Now, you could solve this by multiplying out the parentheses, combining like terms, and then seeing if it factors or these other properties. But because I have the parentheses squared, the variables inside, and there's no other variables, what if I do this? And now I don't want to have this parentheses squared, so I can actually take the square root of both sides. Whoops. 1 plus or minus 2. Add 1 to both sides. So then you get two solutions. 1 plus 2 is 3. 1 minus 2 is -1. And there you go. Let me look at the first example we did. Someone may say, well, how about let's use the square root property to solve this equation. Well, once again, if you try and get the x's on one side, and you say, well, let's take the square root of both sides, we can't take the square root of x squared plus 6x. You can't take the square root of these separately. So the square root property doesn't work for this. It works for these kinds of equations. Now the third kind of, so the first two, factoring and square root method, they work sometimes. And usually, if you can use them, it oftentimes makes the problem pretty easy to solve. However, the third method to solving And actually, in my experience, for me and students, most people do not use this method to solve quadratic equations. The whole principle of completing the square is used for other reasons in math, so it's a good skill to know, but it's usually not used for solving quadratics. But it can be. As a matter of fact, completing the square is a method that will work every time. And the reason most people don't do it, it's sort of perceived as a little bit of extra work. Once you do it a few times, it's not that hard, but it's just not a method people use a lot. So let me just go through the steps and show you how to complete the square. First of all, you have to make sure, let me give you steps. No coefficient for the squared term. I can't have a 2 here or a 3. If I have an equation like this, first thing I have to do is get rid of that 2. Normally what you do is you divide both sides by 2, so you get x squared minus 5 halves x plus 1 half equals 0. All right, you cannot have a coefficient on the squared term. Here, we don't have one to start with. Next, I'm going to move the number to the other side. So I'm going to subtract 5 from both sides. Now this is my little term. I'm sure the book doesn't say to do it this way. I call this perform the special calculation. Special calculation is when you take the middle term coefficient, you always divide it by 2, and then you square it. I call this my middle term, right? Used to be the middle term. I still call it the middle term. So you take the middle term, divide it by 2, and you square the whole thing. So that's 3 squared. All right, so this is, I just did my special calculation. Now what do I do with it? I'm now going to add this special calculation to both sides. And now I'm going to factor my trinomial here. And as it turns out, this is a special trinomial. It's called a perfect square trinomial, and it always factors the same way. It's always going to be parentheses squared. I'm going to have my variable here. Whatever that sign is, if it's a negative or positive, that's what goes here. This right here, I take the square root of that number, and it goes here. It's always the same pattern every time. Add these together. So look what I have here. This looks just like the problem I had when I said use the square root property. Matter of fact, that's what I'm going to do. To finish solving this, I'm going to take the square root of both sides. I'll say the last step is just to solve. Square root of both sides, which would be x plus 3. Square root of 4 is plus or minus 2. So if I subtract 3 from both sides, 2 solutions. Negative 3 plus 2 negative 3 minus 2. And if we look, when I factored, what were my solutions? Same thing. So this is actually a trinomial that factored, but I want to show you how to solve it using completing the square. There are going to be let me quickly I'm trying to think of a quick problem. This does not factor. If I try to solve it by completing the square, I'm going to do it very quickly because I'm running out of time. I think I have to finish this classroom. Special calculation. 12 divided by 2 is 6. 6 squared is 36. Add 36 here. Add 36 here. This is x plus 6 squared equals 35. Take square root of both sides. X plus 6 equals plus or minus square root of 35. So in my solution, I end up with a square root, which means this would not have factored. I could not have solved this problem by factoring. I had to use completing the square, or in the next video, we'll discuss the fourth method using the quadratic equation. But let me stop this video for now, and in the next video, we'll pick up this fourth method, which is probably the most commonly used method of solving quadratic equations.